Write and solve an absolute value inequality for this situation. The accuracy of a certain stopwatch varies by 5%. What this means is that when you time something, the time that it shows on the screen may be off as much as 5% from the actual time. And interestingly enough, that's 5% either above or below. So it's either 5% higher than the actual time or 5% than 5% lower than the actual time. If the stopwatch shows a time of 3 minutes and 26 seconds for an athlete's 800-meter run, then X is the actual time. Okay, so we're saying that's the time that they got, but then X is the actual time, and 0.05 times X is the potential amount of error. Use this information to write your equation and determine the range of possible times that that the run may actually have taken. Well, the first thing I'm doing is instead of dealing with this 3 minutes 26 seconds, I want to turn everything into seconds. So I'm going to take, and I don't know that I have to do this, but I just feel like it would be easier to work with. So I've got 3 minutes, and I know every single one of those minutes contains 60 seconds. And then I had an extra 26 seconds, because remember the time was 3 minutes and 26 seconds. So 3 times 60 plus 26 ends up being 206 seconds. So this is the time in seconds, right? Not minutes and seconds. It's 3 minutes, 26 seconds is the same as 206 seconds. And I'm also noting that the actual time is X, and the recorded time on the stopwatch is 206 seconds. That's what we just calculated here, which is the 3 minutes and 26 seconds expressed as seconds. So here's my absolute value inequality. If I look at the difference rather between the recorded time, right, and the actual time. Now I don't know what the actual time is. I'm calling it X, right? If I look at the difference between those and take the absolute value, so I don't know if it's a positive number or a negative number. It could be that the difference was positive or negative depending on if my actual time was longer or shorter than the 206 seconds. But I know that that error, that amount that it's off, is less than or equal to 5% of my actual time. So let's think about this a little bit more. This is like, let's not go crazy here. So, let's say that X is the amount of time that it actually took me to run the race. I know that this watch can be off by as much as 5%. So what I'm saying is that the error in the timing is no more than 5% of the actual race time. And I guess one way that you can say no more than, right? It's less than or equal to 5% of the actual race time. Now, this inequality, right, we need to solve this thing, and it is a less than statement. So when we have these inequalities that involve less than, right, they end up being, it's a compound equation. There's two equations here, and they're joined by and. And basically, let's say that this 206 minus x was a positive number, just like that, then this would be less than or equal to 0.05x. That's one way to write it. Now, if this 206 minus x was a negative number, what I would do is I would flip the direction of this inequality and I would multiply this by a negative 1. So I'd write 0.05, negative 0.05x. It's greater than or equal to negative 0.05x. And the two, things we banty about in class is that, in terms of this inequality symbol, if it's less than, right, we're thinking and if we have one that is, if it's greater, we're thinking or. So we know if our absolute value is on the left-hand side, the absolute value is less than something, it's an and that joins the two things, the two separate equations we get. If it's greater, it's an or that joins them. So and or. And then the other thing is, as I'm setting this up, right, you'll notice that this matches exactly what's inside. Same, this is the same symbol, and this is exactly the same. So everything is the same on one side. On the side where I realize that the 206 minus x could be negative, this is the same, and then I flip the direction of my inequality, and then this side becomes the opposite. And I've been saying keep, flip, opposite. Keep the 206 minus x the same, flip the direction of the inequality, and then write the opposite of that other side. So that's a lot of setup and a lot of background. And you might want to, you know, kind of steep yourself in that, because they're just tools that'll help you deal with this situation and situations like this. So how do I solve this inequality? Well, I'm thinking what I'm going to do is I believe I'm going to add x to both sides. Maybe that's okay. So I'm going to add 1x to both sides. So over here I get 206 is less than or equal to, this would have to be 1.05x. And on the other side, I'm going to add x also. So that would be 206 is greater than or equal to, if I add x to that, that would be 0.95x. So I need a little computational assistance here. So let's go ahead and take the 206, and we're going to divide that by 1.05. And when we do that division, we get that over here, x is, it's kind of awkward how I'm saying this, but I'm going to write this here. I'm going to write the 196, uh-oh, I forgot it, really. 196.2, I guess. 0.2 is, see, this is awkward, right? Because I don't like talking about these backwards. So I'm going to rewrite this. I'm going to just flip the order around. What this is saying is x is the greater thing. So I'm going to say x's are greater than or equal to 196.2. So that's the lower bound, right? I think that's the lower bound. I could have, if my recorded time was 206, my actual time could have been much slower than that. I mean, faster. I could have done the race in 196.2 seconds. So this is the lower bound. Now, what's the upper bound error? So my calculator again, this time I'm going to take the 206 and I'm going to divide that by 0.95. And when I do that, I get 216.8. So we'll say that 216.8 like this, but this is awkward, so I'm going to write it this way. X's is the smaller thing up here, right? X's are less than or equal to 216.8. So if I'm thinking about this in terms of a number line, um, I'm just going to say that this is the number 200. And over here, I've got this dot, and I'm just marking this. It's 196.2, and above it there's this other dot, and actually it's equally spaced from the 200. It's 216.8, and what we're saying is that our actual time is somewhere in between those two, right? Actually, I don't think that. I think it's equidistance from the 206. Probably I should put 206 in the middle here. This would be visually more accurate then. So my actual time is somewhere between, it's 196.2 and 216.8. And honestly, it's not the stopwatch. The problem is always the human error. It's just, it could be difficult to just start and stop those stopwatches on time. So that's why a lot of big meets, you've always got, the lasers that are measuring start and stop, and also multiple timers just help kind of eliminate human error. So we don't know how fast you went, but it could have only taken you 196 seconds, or it could have taken you 216, but the time we've got on paper is 206.